Now we will see what are the problems which has to be solved by numerical methods. That means numerical methods for solving problems arising in different areas. What are those include? They include solution of nonlinear equations, solution of system of linear equations, numerical differentiation, numerical integration, and solution of initial value problems. Now we have to study so many areas where numerical methods are applied to find the solution. They may be solution of nonlinear equations, system of linear equations, numerical differentiation, numerical integration, and solution of initial value problems. So these has to be studied in order to know what are the differential procedures, what are the numerical procedures. Now we will see one by one. First is solution of nonlinear equations. Solution of nonlinear equations. What are nonlinear equations then? So nonlinear equations are mainly, it comprises of two types of equations. One is algebraic equations, another one is transcendental equations. So algebraic equations and transcendental equations. Now first we have to see how the problem may be. The mathematical problem is of the form f of x is equal to 0. Here f of x may be algebraic function or maybe transcendental function. Algebraic function means it's either a polynomial in x. Algebraic function is nothing but it is a polynomial in x. And transcendental functions are those functions which include trigonometric, logarithmic, exponential functions and so on. So that means algebraic equations are those equations which involve polynomials of some finite degree. Polynomials of finite degree. And transcendental equations are those equations which involve infinite series expansions. You can observe, so trigonometry functions are infinite series having, logarithm is also having infinite series expression, and exponential functions are also having infinite series expressions. Therefore those polynomial equations which is having finite degree are called algebraic equations, and those involving infinite series expressions are called transcendental equations. Our aim here is to find the solution of the form f of x is equal to 0, where f of x may be algebraic equation, algebraic function or transcendental function. So these algebraic equations and transcendental equations together constitute nonlinear equations. Our aim now is to study nonlinear equations solution, for their solution. Now there may be some different methods of solution. So the methods of solution for the nonlinear equation f of x is equal to 0 may be, they may be direct methods or iterative methods. So what are the direct methods then? Direct methods are those methods which give exact value of the root in a finite number of steps. So direct method means they will give exact value of the root in a finite number of steps. And what are iterative methods? They are based upon successive approximation. They are based on successive approximations, and they are result in sequence of approximations. So here we will get sequence of approximations, which sequence will be converging to the root. That sequence will be converging to the root. Now in case of direct methods, we are having all the roots at a time, means we are getting all the roots in a single step. So at a time we are getting all the roots. In case of iterative method, we will be getting only, that method will give only one root at a time. So if we get only one root at a time, that will be iterative method. If all the roots are obtained in a single procedure, that will be direct method. So methods of solution may be, they may be direct methods or maybe iterative methods. So direct methods will give exact value of the root, and all the roots are obtained in a same time. And iterative methods are those methods which are based on successive approximations, and those successive approximations will lead to sequence of approximations that will be converging to the exact root. So here we will be having only one root at a time. Now we are focusing on iterative methods as we are studying numerical methods. So we are focusing on mainly on iterative methods. Here we are having two types of iterative methods for solution of nonlinear equation of the form f of x is equal to 0. They may be bracketing methods and opponent methods. Here bracketing methods are also called as interpolation methods, and opponent methods are also called as extrapolation methods. Now we will see one by one. So what are bracketing methods then? Here the bracketing methods are those methods in which the root lies within the interval which is obtained from intermediate mean value theorem. So there is one theorem which is called intermediate mean value theorem, from which we will be having one interval, so that may be AB. So here the root lies between the interval. So those are called as bracketing methods. This means they are bracketing the root. This interval is bracketing the root, therefore they are called as bracketing methods. Here if we have a interval which is obtained from intermediate value theorem, the open methods are those methods where the root may be outside the interval. So therefore they are called as open-end methods or sometimes extrapolation methods. Now we will see what are the bracketing methods, what are the popular bracketing methods and what are the popular open-end methods. The popular bracketing methods include bisection method and regular fallacy method, and popular open methods include secant method, fixed point iteration method and Newton-Raphson method. So we have to remember bisection method and regular fallacy method are the bracketing methods, and secant method, fixed point iteration method, Newton-Raphson method are the open-end methods. So here we have mentioned one theorem, intermediate mean value theorem, from which interval AB is obtained. So this interval is called test interval. So this is called test interval here because we are testing for the root, therefore this is called a test interval. If the root lies within the test interval, that will be bracketing. If the root is outside the, sometimes it may be inside, sometimes it may be outside, so those are called open-end methods. Now we will see what is intermediate mean value theorem. So here in all the cases f of x is equal to 0. In the case of f of x is equal to 0 problem, here f of x is assumed to be continuous. So therefore we are applying the intermediate value theorem. So the intermediate value theorem states, if f of x is continuous in the interval, the closed interval AB, and f of a and f of b have opposite signs, then the equation f of x is equal to 0 has at least one root between a and b. This means f is continuous, f of a and f of b have opposite signs means f of a and f of b opposite signs. Opposite signs means f of a is greater than 0 and f of b may be less than 0, or sometimes f of a is less than 0, f of b is greater than 0. This means they are having opposite signs. Then there will be at least one root between the interval AB. So that is here f of f may be like this. Here this is a, this is a f of a, this is b, b f of b. So you can observe f is continuous and the f of a and f of b are opposite signs. F of a is greater than 0 and f of b less than 0. Then there is at least one root between the points a and b. So that is there is at least one root between the interval AB. So root means it is the point where the function cuts x-axis. So this will be the root. So this is how intermediate mean value theorem is applied, and the test interval is obtained. So and we have to know how the test interval is obtained in the upcoming methods. Now we will be having one more concept, that is called convergence of methods. So before studying the different methods, we have to know convergence of methods. Convergence means how the method will be reaching to the root. So we have various methods converge to the root at different rates. So then what is rate? The rate of convergence. So it is nothing but the fastness of convergence is represented in terms of rate. So it is nothing but the fastness of the convergence. So rate will be nothing but how fast the root is reaching, how fast the method is reaching to the root. How fast the method is reaching to the root. The method is reaching to the root. Now again, so that is defined as, rate is defined as the rate at which the iteration method converges is the rate of convergence. So in which rate the method is converging is nothing but the rate of convergence. So that is given in terms of one table, which is in terms of order of convergence. So what is order of convergence then? So if you have a limit which is in which n is tending to infinity with the absolute value of error in the n plus 1th iteration and absolute value of nth iteration with the power p. So if this limit is equal to c, which is a constant, then the superscript p is called order of convergence, c is called asymptotic error constant. Asymptotic error constant, which is nothing but asymptotic error constant. So here, if suppose the limit of the n plus 1th iteration to the nth iteration with the power p is equal to some constant c, then this p is called rate of convergence. So this p is called order of convergence or rate of convergence, and c is called asymptotic error constant. So we have to remember e raised to n. So this is equal to c. So limit as tends to this will be c. Here en is error in the n plus 1th iteration, en is the error in the nth iteration. If en plus 1 to the ratio of n with the power p is equal to some constant, then this p is called rate of convergence, and c is called order of convergence. C is called asymptotic error constant. So here p is rate of convergence or order of convergence, and c is asymptotic error constant. This we have to remember because these are used in further discussion. Asymptotic error constant. Now we will see some of the bracketing methods. So we will see the bracketing methods. That means we will be having one test interval which is obtained from intermediate mean value theorem. This interval is obtained from intermediate mean value theorem, and the root is in between the points A and B. So now the first method is bisection method. Then what is bisection method? You have to know the bisect method is sometimes called as half interval method, or interval halving method, or binary chopping method, or Bolzano method. So the bisection method is having different names, which are half interval method, interval halving method, binary chopping method, or Bolzano method. These names should be remembered because sometimes they ask with a different name. Now what is the procedure for bisection method? Here, with the help of intermediate mean value theorem, we are having a one test interval AB. So how AB is obtained? Here the function is here the equation is of the form f of x is equal to 0. This is our mathematical problem. Here what we have to do is we have to put different x values which are from the integers, maybe -1, 0, 1, 2, so on, for those consecutive integers where f is having opposite signs. The x1 and x2 are two consecutive integers such that f of x1 is greater than 0 and f of x2 less than 0. Otherwise, f of x1 is less than 0 and f of x2 is greater than 0. Here x1 and x2 are consecutive integers. So this interval is obtained by intermediate value property, which is based on putting the consecutive integers such that the f values have opposite signs. So this is how AB is obtained, and the first iteration for the bisection method is given by initial approximation is given by x0 is equal to a plus b by 2. This is the starting point, this is the end point. If we chop the this interval into exactly half, that will be the first iteration, that will be x0 is equal to a plus b by 2 is the first iteration of bisection method. Now in order to know the second iteration, here suppose we assume that f of a is greater than 0 and f of b less than 0. Suppose we assume, we can assume f of a less than 0 and f of b greater than 0. Now if f of x0 is greater than 0, then we have to take these 2 points x0 and b. So these two having opposite points, then the interval will be x0 to b. Again the second iteration will be x1 is equal to x0 plus b by 2. Again we have to check for the sign of f of x1. If suppose f of x1 is less than 0, then we will be having here f of x0 greater than 0, f of b less than 0. Now f of x1 is less than 0 means we have to take x0 and x1. So this will be x0, this is x1. Here the third iteration will be x2 is equal to x0 plus x1 by 2. This is how the procedure goes, and we have to stop at that stage where the two consecutive roots have very, so this is n and this is n plus 1, the difference is very less. Sometimes the difference may be given, it is in terms of error tolerance. This may be less than or equal to epsilon. Here epsilon is nothing but error tolerance. Sometimes that may be given as epsilon is equal to 0.0001, or sometimes they say the roots are corrected to 2 decimal places. 2 decimal places means 2 decimal means. So if suppose the first root is 2.3546, then the second root will be 2.3556. So these two are having same digit for the 2 decimal places. Therefore, then we have to stop at this stage. This is how we can find the root which will be obtained at the some iteration, which is based on either corrected to some decimal places or where error tolerance is given. So this is about how to find the approximate root by bisection method. Now for the first iteration, the interval is AB. So difference between after the first iteration, we have x0 is equal to a plus b by 2. Then the first the length of the interval after the first iteration become b minus a by 2. So this will be chopping at the half. Therefore after the first iteration, the length of the interval will become b minus a by 2. Likewise at the nth step, we have the difference as b minus a by 2 power n, and at the n plus 1, b minus a by 2 raised to n plus 1. This is for nth iteration, this is for n plus 1th iteration. This is nothing but the length of the interval. This is nothing but the length of the interval, means they are coming very close. Now if suppose error tolerance is mentioned, this will be very small. Therefore we have written at the nth iteration the length will be very small and which is less than or equal to epsilon. So we apply log for both sides, then we will be having this expression, which is given by the ratio of log of modulus of b minus a by e to the ratio of log of 2 to the base e, which is just is equal to n. Here a and b are endpoints, epsilon is the error tolerance, and n is the number of iterations. This formula gives the number of iterations required for arriving at the accuracy epsilon. So if suppose somebody asks what is the number of iterations required for arriving at the accuracy epsilon, then this will be the formula. You have to remember this formula. Now we have to study the rate of convergence of bisection method. Therefore we will be having en plus 1th error and nth error. So here we know that the length of the interval at the nth step is this will be give the error. So at the n plus 1 state, this will be this. So this will give error for n plus 1, this is for error n. Now taking en by n plus 1, this will be b minus a by 2 power n plus 1 to b minus a by 2 power n. So cancelling out, this will give 1 by 2. Now we have en plus 1. So we can take absolute sum because we don't think about the sign here. Power 1 is equal to 1 by 2. Here the power is 1, therefore p is equal to 1, therefore order of convergence is equal to 1 and c is equal to half. Therefore asymptotic error constant will be half. Therefore for the bisection method, order of convergence will be 1, which is called linear convergence, and asymptotic error constant will be half. So this has to be remembered. This is all about bisection method. Now we will see some questions on bisection method which has been previously asked in different exams. Question of KSET 2015. The order of convergence and asymptotic error constant in bisection method are respectively. Option 1 says 1, 1, option B 1, 1 by 2, option C 2, 1, option D 2, 1 by 2. Just now we have studied order of convergence is 1, asymptotic error constant is half. Therefore the option is here order of convergence means en plus 1 by en is equal to b minus a by 2 power n plus 1 divided by b minus a by 2 power n. This is equal to half. Therefore en plus 1 by en to the power p is equal to c, means here p is equal to 1, c is equal to half. Therefore order of convergence will be asymptotic error constant will be half. The correct option is option 2. Now we will see one more question on bisection method which has been asked in KSET 2016. One root of the equation e power x minus 3x square is equal to 0 lies in the interval 3, 4. The least number of iterations required for the bisection method so that the modulus of error is less than or equal to 10 raised to minus 3 is. So here they have given error bound, so that is error tolerance epsilon is equal to 10 raised to minus 3 and a is equal to 3, b is equal to 4. Now we have to find the number of iterations. We have formula for number of iterations as b minus a by 2 power n is less than or is equal to epsilon. So just put b and a, b minus 2 power n is less than or is equal to 10 raised to minus 3. So taking this out, this is 1 by 2 power n is less than or is equal to 10 raised to minus 3. So this will be 2 power n is, now just we have to take multiply this side and this side. So it will be 10 raised to 3 is less than or is equal to 2 power n. So we have to go on put n value so that 2 power n is greater than or equal to 1000. So just put n is equal to, here we have options 4, 6, 10 and 8. So we will put 4. So 2 power 4 will be 16, 2 power 6 will be 64, 2 to the 8 will be 256. So 2 power 10 will be 1024. So here we can observe 2 power 10 will be 1024, which is greater than 1000. Therefore n should be is equal to 10. Therefore the least number of iterations required for the bisection method so that error is less than or equal to 10 power minus 3 is 10. Therefore option 2 is correct. Now a question of MSET 2016 from paper 3. The question says if f of x is a real continuous function in AB and f of a into f of b less than 0, then for f of x is equal to 0, there is or bracket r dash dash in the domain the closed interval ab. Options are 1 root, an undeterminable number of roots, at least one root, no root. So this is nothing but f is continuous and f of a into f of b less than 0. This means fa and fab are of opposite signs. Then from intermediate mean value theorem, there is at least one root. One root of f of x is equal to 0 between a and b, or in the interval or in closed interval ab. So just applying the intermediate value theorem, we can conclude there is at least one root between the points a and b, or in the interval ab. Therefore option C is correct. Now we will see another bracketing method, that is called regular fallacy method. Sometimes regular fallacy method is also called as false position method, linear approximation method, or linear interpolation method. Here also we will be having the test interval which is obtained from intermediate mean value theorem. So here also we are putting for f of x equal to 0, which is a given problem. If we have to put x values from the set of integers, so that for two consecutive integers, so they are having opposite signs, or sometimes x1 and x2, or sometimes here we are taking x0 and x1. So x0 and x1 are, no, not this. So we have to put x values from set of integers such that if suppose f of a is greater than 0 and f of b is less than 0, or sometimes f of a is less than 0 and f of b is greater than 0, such that a and b are consecutive integers. Then from IMVT, intermediate mean value theorem, the root lies in the interval, the closed interval ab. So this is how we have taken ab. Here we should remember that a and b are consecutive integers. Now from the IMVT we have test interval ab. Now we have to take any 2 points between a and b, so which are x0 and x1. Then the first iteration of the regular fallacy method is given by x2 is equal to x0 f of x1 minus x1 f of x0 divided by f of x1 minus f of x0. So this is the first iteration formula for regular fallacy method. Now after the first iteration, in order to go to second iteration, what we have to do is just we have to check what is the sign of f of x2. So based on the sign of f of x2, we have to together so f of x2 with either a or b. Here if f of x2 is less than 0, then we have to choose b such that f of b less than 0 and f of x2 is less than 0, f of x2 is greater than 0. No, here if f of x2 is less than 0, here we have f of x0 value and f of x1 value. So if it is greater than 0 and if it is less than 0, then we have to club x2 with x0. If otherwise, if f of x0 is less than 0 and f of x1 is greater than 0, then we have to club with x2 with x1. So then if you take this condition, that will be x3 is equal to x1 f of x2 minus x2 f of x1 divided by f of x2 minus f of x1. This is how at each step we have to check the sign of the iterated value and we have to proceed as in the case of bisection method. Now the order of convergence for regular fallacy method is 1, because en plus 1 by en to the power 1 is equal to constant. Don't worry about the derivation and all. Just remember the order of convergence of order of convergence of false position method or regular fallacy method is 1, which therefore it is called linear convergence. Therefore we have to remember for second method the convergence is linear. This is all about bracketing methods. We will see open methods in the next video.